Okay, we're now in AM Unit 4, Lesson 9, Exponential Equations again. Only this time we're going to solve these equations using logarithms. Now if you remember back in Lesson 7, we solved exponential equations and we used common bases, and then we did the one-to-one property. Well, what if a common base is not possible? So for example, 3 and 80. It's not going to be possible to find a base for 80 that matches 3. So this is the next level. What do we do here? Well, we are going to use logarithms, and you're going to need the calculator for this. There's no way around that. All right, so we're going to start off. Whereas last time we got matching logs and then we dropped the log and went one-to-one, now we're going to go backwards. We're going to take this and we're going to put them as logs. So the log of 3 to the x power is equal to the log of 80. Okay? Now what we're going to do is, let's expand this out. We're going to take the exponent. So I have x equals log 3 equals log 80. Now, I want to know what x is, so I'm going to try to get rid of everything attached to the x. Well, what's attached to it right now is a logarithm, and it's attached by multiplication, so I'm just going to divide both sides by that. Now, how does this help? Well, it cancels this, so now I have log 80 over log 3. Now, this is a number. Okay, what I did is I got my x out of the exponent and I got rid of everything else. I manipulated this around. Well, what is log 80 divided by log 3? That's where your calculator is going to come in. You are going to hit log 80 and close it with a parenthesis, hit division, log 3, close parenthesis, enter, and you get 3.9887. So that's what x is, okay? And then, yeah, you'd want to fill it back in, make sure there's no problem, okay? Now, for number 2, we have e to the x is equal to 140. All right, what kind of a log do you use when you have a base e? Do you remember that? It wasn't just the common log, but it was the natural log. So we're going to rewrite this one as ln of e to the x is equal to ln 140. All right, once again, the product property or the power property backwards is saying x times ln of e is equal to natural log 140. Divide both sides by natural log of e. Remember, e is a number, okay? It's like pi, so it's not a variable. E is not a variable, it is a number. So now what I have is that x is equal to natural log 140 over natural log of e, and we can put that in the calculator and we will find that it is 4.9416. And yes, I see that it is not going to give me a problem if I fill that back in, and I will get the correct answer. So I did check for extraneous solutions, okay? All right, let's move forward. Okay, number 3 says 5 to the x plus 1 is equal to 18. And once again, there's not a common base possible between 5 and 18. And for the rest of these problems, and I'm going to say that over and over, that's why we're doing these problems this way, is because there's not a possible common base. So once we identify that, we're going to go to taking the log of each side. So I've got the log of 5x plus 1 is equal to the log of 18. Then I'm going to use my power property to whip that around. So now I have x plus 1 times log 5 is equal to log 18. Now I'm going to divide both sides by log 5. You have to keep your eye on your variable because that is what you are trying to whittle away and eliminate everything attached to it. All right, so now when I do this, these two cancel out. This is a number. And I can put this in my calculator, and it is going to tell me that the log of 18 divided by the log of 5 is 1.7959. Remember, we're going to round off to 4 decimal places. All right, and over here, I now have x plus 1. All right, when I subtract 1 from each side, I'm left with x is equal to 0.7959, and plugging that back into my original equation and using a calculator will show me that that is the correct answer. Okay, number 4, 1/3 to the 2x minus 5 power is equal to 120. So let's take the log of each side. I'm going to have the log of 1/3 2x minus 5 is equal to the log of 120. All right, using my power property, I'm going to whip that around. So now I have 2x minus 5 times the log of 1/3 is equal to the log of 120. Divide both sides by log of 1/3. Okay. These two cancel, so I have 2x minus 5 here, and I'm going to plug that one into the calculator, and it's going to give me negative 4.3578. Okay, now to solve the rest of the equation, what are you going to do? Well, you're going to add 5 to each side, and then you're going to divide by 2. Okay, so I'm just going to do those steps in the calculator, and it's going to spit out 0.3211. And filling that back in for x and simplifying down will show you that that's the correct answer. Okay, let's look at number 5. e to the 3x plus 25 is equal to 108. Now our first step was to isolate the exponential. So here is my exponential. I need to get rid of the 25 first. So I'm going to subtract 25 from each side. So that's going to leave me with e to the 3x is equal to 83. All right, now we're ready to take the log, but remember, since we're dealing with base e this time, we're going to need to take the natural log of each side. All right, now I'm going to use my power property to whip that exponent around there. So I'm going to have 3x natural log of e is equal to the natural log of 83. And remember, you've got to start thinking of natural log e as a number, okay? So now I'm going to get rid of it by dividing both sides by natural log e. All right, these two cancel out. So I have 3x is equal to, all right, natural log of 83 over natural log e is 4.4188. That's done in the calculator. Now you're going to divide both sides by 3. So x is going to leave you at 1.4729. Remember, we're going out 4 decimal places. Okay, now number 6. Negative 2 times 8 to the 4 minus x is equal to negative 50. Identify your exponential. It's right here. Constant base, exponent is a variable, and we want to isolate it. It's multiplied times negative 2. So to get rid of negative 2, I'm going to divide it on both sides. Now I have 8 to the 4 minus x is equal to positive 25. All right, it's isolated, so let's take the log of each side. Log here, log here. I'm going to take this exponent and whip it around so that now I have 4 minus x times log 8 is equal to log 25. Divide both sides by log of 8. These two cancel. This is a number, and if you punch this into your calculator, it is going to tell you that that is 1.5480. And we have 4 minus x left over here. Okay, now we're going to subtract 4 from each side, so that's going to give me negative x is equal to negative 2.4520. But remember, I don't want to know what negative x is. I want to know what positive x is. So I'm going to multiply both sides all the way through by negative, and that's simply going to make each side positive. So my final answer is 2.4520. Okay, so number 7 is a hot mess here. So let's identify our exponential, and then let's start getting rid of things that are attached. 2/3 is attached by multiplication, and 1 is attached by subtraction. So we want to undo the addition subtraction first. So we're going to add 1 to each side. Now I have 2/3 times 2 to the x minus 6 is equal to 42. All right, now how do we get rid of a fraction? It's multiplied by there. Well, if you'll remember, a fraction times its reciprocal is equal to 1. So if I multiply this side by 3/2, those will cancel out. But whatever I do to one side, I have to do to the other. Now if you multiply 42 by 3/2, that's going to give you 63. And then we have the 2 to the x minus 6 over here. And our exponential is isolated, so we are ready to take the log of each side. So log here, log here. Now I'm going to take the power and bring it around here so that I have x minus 6 times log of 2 is equal to log of 63. And same thing, we're going to divide both sides by log 2. Okay, these two cancel out, so let me come over here. Now I have x minus 6 left, and if you put in the calculator log 63 divided by log of 2, that is going to give you 5.9773. And we're just solving, so we're going to add 6 to each side. So x is equal to 11.9773. Okay? Okay, here's number 8. So let's identify our exponential. Here it is right there. 4 to the 2x plus 7. So I'm going to have to get rid of a negative 2 that is multiplied times it and a 9 that is added to it. So let's get rid of the addition first. We're going to subtract both 9 from each side. So now I have negative 2 times 4 to the 2x plus 7 equals negative 55 minus 9 is negative 64. All right, now I'm going to divide both sides by negative 2. So I'm going to be left with 4 to the 2x plus 7 equals negative 64 divided by negative 2 is a positive 32. And my exponential is isolated, so I'm ready to take the log of each side, take that power, bring it around. So now I have 2x plus 7 times log of 4 is equal to log of 32. Divide both sides by log 4. Okay. These two cancel out and leave me with 2x plus 7. These two, when I put them in the calculator, they are going to give me an answer of 2.5. So now I am subtracting 7 from each side. So that's going to leave me 2x here and give me negative 4.5 there. Divide both sides by 2. And x is equal to negative 2.25. And be a good idea to plug that back in, make sure it works. I did, so this is not an extraneous root. Okay, let's look at number 9. Now we have two exponentials this time, and they're both isolated, so let's go ahead first, and we're just going to take the log of each side. All right, our next step is going to be to take that exponential and fling it around in front. So now I'm going to have x plus 5 times log 2 is equal to x minus 2 times log 3. Now, this next step is going to look kind of crazy, but this is actually a pretty common thing to do when you have your variable buried inside of a binomial on both sides. We've got to separate it and then get them together. So what we're going to do here is we're going to distribute, multiply the log times both of those. So what I have now is x log 2 plus 5 log 2 over here. And I'll put those in parentheses. All right, we're going to do the same thing here. Now I have x times log 3 minus 2 times log 3. Okay. Now, this is a variable term and this is a variable term, and they're on opposite sides. And this is a constant term and this is a constant term. So I'm going to switch everything. And how I'm going to do that is, I'm going to do it in one step, so pay attention. I'm going to move this over here by subtracting it from each side. So I've got minus x log 3. Okay? Then I'm going to move this over here by doing the opposite. It is added, so I'm going to subtract 5 log 2 from each side. All right, so what that's going to do is these two cancel, and what I have left over here is the x log 2 minus x log 3. All right, now over here, these two cancel out, so I have minus 2 log 3 minus 5 log 2. And I know that looks crazy, but you have to understand that is a number. You can put this in your calculator and it will give you a decimal, one single decimal, so keep that in mind. Now, the problem is here, I need to get this x out. Well, it happens to be a common factor. So what I'm going to do here is I'm going to divide the x out of both of these. Let me make that black. If I divide x out of here, what do I have? Log 2. And if I divide the x out of here, what do I have? Log 3. Okay? And it's all equal to all of this crazy stuff. Okay? All right, now here's my x. I need to get rid of this. It's multiplied, so what I'm going to do is divide all the way through by log 2 minus log 3. Whatever you do to one side, you have to do to the other. So this is going to be divided by log 2 minus log 3. Now if you notice, all of this right here is just a number. There is no variable here. So I can start, these two will cancel out. I can come up here and do x equals. If you put all of this into the calculator, it is going to tell you nothing but negative 1.54. And I want you to be sure that you practice putting that into the calculator to make sure you know how to do that. Okay? Because it's not as easy as it looks, which it doesn't look all that easy, but you need to practice that. Put all this into the calculator and make sure that you can get this answer. Okay? Let's move on to the next one. Okay, so for number 10, you can see it looks very much like number 9. So we're going to be using that same technique, and you'll see the more you do it, the easier it gets, I promise. All right, we identify the fact that we have two exponentials. They're already isolated. We can't get a common base, so let's go ahead and take the log of each side. Then the next thing we're going to do is take the exponential and whip it around in front. So I'm going to have 2x minus 1 times log of 8 equals x plus 3 times log 5. Now you see, just like in that other one, we have a binomial here and a binomial here that contains our variable attached to a number. So we're going to have to use the distributive property, first of all, to spread it out, and then we can start getting rid of stuff. So when I use the distributive property here, I'm going to have 2x times log 8 minus 1 log 8 equals, and then the same thing here. So I'm going to have x times log 5 plus 3 times log 5. Okay, so now I would like to have my term that has an x over here with the 2 and my term that has no x's over there. So let's do that all in one step. To move this one, I'm going to subtract x log 5 from each side. And then to move this one, it's negative, so I'm going to add 1 log 8 to each side. Now let's see what happens. Here I've got 2x log 8 minus x log 5. These two things cancel out. All right, over here, the first two cancel out, so I have 3 log 5 plus 1 log 8 left. All right. Now, it's better, even though it doesn't look like it. This is all number, and I see I've got my variables spread out. Well, how can I pull those out? Look for a common factor, and the common factor here is just x. So when I divide x out of there, what do I have left? Well, here I've got 2 log 8 left, and when you divide x out of here, what do you have? Minus log 5, okay? Equals all this stuff over here. And that 1 is hard to keep identifying. You don't really, 1 times anything is the identity, so you could leave that off if you want to. All right, now that I have x over here by itself, what am I going to do? Well, I'm going to divide by this 2 log 8 minus log 5 on each side. 2 log 8 minus log 5, okay? Over here, these two things cancel, and what do you have left? X equals, all right, you're going to put this all in the calculator, and it is going to spit out the number 2.71. And once again, I want you to put that in the calculator and be sure that you can get that answer, okay? Okay, for number 11, we've got a similar situation, so we should know how to deal with it. The first thing we're going to do is do the log of each side. And how do I know to go ahead and do that? Remember, we've looked and we can't get a common base between 4 and 11. So using the common base method, like in lesson 7, that's out. Are my exponentials already isolated? Yeah, they're on both sides, but they're all alone. So the only thing I can do now is go to logs. That means I'm going to take my powers on each side, flip them around. So now I'm going to have x minus 3 times log 4 here equals 3x plus 2 log 11 there. Now I realize that since I have binomials on each side and I need that x out of there, well, first I'm going to have to distribute. That's going to let me get rid of the parentheses. So I'm going to distribute a log 4 into here and log 11 into here. So this is going to be x times log 4 minus 3 times log 4. And then over here, I'm going to have 3x times log 11 plus 2 times log 11. Now, and you keep in mind what's already a number. Those two things are already numbers. So if I can get them together, then I can get the variable terms together on the same side and start whittling on those some more. So I am going to add 3 log 4 to each side. And what that's going to do over here is cancel this out. Okay? Then I'm going to come over here. I want to move this over to the other side. So I'm going to have to subtract it from here and from here. Okay? Now let's clean this up. So this and this will cancel. Now, what do I have over here? Well, I have x log 4 minus 3 log 11, and this was 3x. This is 3x. Don't let me lose an x. Okay. Equals, all right, over here, I've just got that 2 times log 11 plus 3 times log 4, which if you put that in a calculator, that just is a number, okay? I know it looks bad, but that really is just a number. Okay, now I have these two terms right here, and I need to get that x out. So I'm going to do that by factoring out a greatest common factor. The greatest common factor between these two terms is just the x. Now what do you have left over? Well, if I divide an x out of this, what I have left over is log 4. If I divide an x out of here, what do you have? Minus 3 log 11, okay? Nothing over here is changing. I still have 2 times log 11 plus 3 times log 4. You really don't want to put it in the calculator and make it into a decimal until you get to the end, because that gives you a more exact answer. Okay, now I'm going to get rid of this by dividing here. Log 4 minus 3 log 11. And guess what? Those two things cancel out, so I just have x equals here. Now when I divide all of this by the same thing, log 4 minus 3 log 11, we're going to put that in the calculator, and that is going to give us negative 1.54. And once again, I know it is tedious, but you need to practice putting this in the calculator to make sure you get this answer. Okay, last one, y'all. Number 12, 9 to the negative 2x equals 2 to the 5x plus 4. Once again, we cannot get a common base. Our exponentials are isolated, so we are ready to take the log of each side. Now we're going to take our exponent and we're going to flip it around and make it a coefficient. So what I'm going to have here is negative 2x times log 9 equals, right here, I'm going to have 5x plus 4 times log 2. Okay, now this one is not a binomial, so there's no need to distribute that. So I'm just going to leave that as negative 2x log 9. But over here, I am going to have to distribute, well, the log 2 into that. So what I'm going to have here is 5x log 2 plus 4 log 2. All right, now which terms have my variable? This one and this one. So I need them on the same side. I'm going to move this one by subtracting it from here and subtracting it from here. Okay. And what that's going to leave me with is negative 2x log 9 minus 5x log 2 equals this 4 log 2. Okay. Take out the common denominator, which in this case is x. And there's no, I know usually when you factor out a greatest common factor, if your leading term is negative, you factor out the negative. But in this case, we don't want to factor it out because that's our variable and we would just have to get rid of it later. So just leave it in there. When I factor x out of all this, I'm going to have negative 2 log 9 minus 5 log 2 equals 4 log 2. And then we're going to divide both sides by this. So I'm going to have x equals, and I'm just going to, nope, I'm going to do it right. So I'm going to divide both sides by 2 log 9 minus 5 log 2, and I'm going to divide this side by negative 2 log 9 minus 5 log 2, okay? These two cancel out, so my final answer, I'm going to have x equals, you put all of this in the calculator very carefully, and it's going to give you negative 0.35. And for the last time, please practice putting that in the calculator and make sure you get that answer, okay? All right, good job, y'all. That is all of lesson 9, and that was rough, but y'all did a good job, okay? I'll talk to you later.